All right, we'll dive into straight lines. We'll tackle graphing and writing equations for straight lines all in one go. So lines or linear functions are functions, except for one type. There's one type of straight line that does not qualify as a function. Can you think of which one? Straight lines have a constant slope. While we can talk about slope for other shapes, including parabolas, the slope in those shapes is not constant as it is for a straight line. The slope's also called the rate of change. We usually label the slope as m, and the y-intercept, the point where the line crosses the y-axis, as b. You cross the y-axis where x is equal to 0. So we have the point, the y-intercept point b, or we can write this as 0, b. That's the xy coordinate. We know we're talking about a straight line if you don't have any powers. If the highest power that x is raised to is a 1, you know you're dealing with a linear function. You can graph a straight line using 2 points, or if you know the y-intercept or any other point, as well as the slope, that will allow you to graph it as well. We'll have a look at lines that have positive slopes, like the one drawn here, negative slopes, such as this one, horizontal lines, and vertical lines. Those are the only straight lines that are not actually functions. So the slope, or m, also called the rate of change, is the rise over run of the function. In other words, the change in y, delta y, divided by the change in x, delta x. So if you have 2 points, the first xy coordinate we'll call x1, y1, and the second xy coordinate, the second point, we'll call x2, y2, you can calculate the slope using the formula given here. In these situations, for question 1, we have 2 points, -2, 5, and 3, -1. And I'm going to go right ahead and label these as x1, y1, and x2, y2. While it doesn't matter which one is point number 1 and which one is point number 2, you want to make sure that y1 is with x1 and y2 is with x2. We'll do the same thing for the second example. y1 and x1 belong to the same point, x2 and y2 belong to the same point. All right, so to calculate the slope for the first point, we use y2 minus y1. So y2 is a value of -1 minus y1, which is a value of 5, divided by x2, a value of 3 in our case, minus x1, so minus -2. So we get -6 divided by 3 minus -2 is 3 plus 2, or divided by 5. Or we can simply write the negative sign out front, because the -6 divided by the positive 5 gives us an overall negative value. So we have -6 over 5. We can show what this looks like on the coordinate plane by plotting both points and connecting them to graph the straight line. So we'll find 2, -2, 5 rather, start. So we'll find -2, 5 in the upper left-hand corner here, and 3, -1 in this lower quadrant 4. We connect the 2 points and extend. We have the slope. We have a picture of our straight line. So the slope tells us how to start at any place on the line and move to a second point. We can move in between the 2 points that we've just got. Because the slope is negative, if we start by moving 6 units up, so we have a rise of 6, we'll then have to go left for the run. Or we can start at the upper point and go down by 6 units, in which case our run is going to be to the right. Let's look at our second example. In this case, the slope is 2 minus -4 divided by 3 minus 0. 2 minus -4 is the same as 2 plus 4, or 6. 3 minus 0 is 3, so our slope is just 2, positive 2. Or if you want to write this as a fraction, this is 2 over 1. Let's plot these points as well. So we have 0, negative 4 on the y-axis, and the point 3, 2 over here. Connecting those and extending gives us our linear function. We knew we had a positive slope. We know the line is going to go up and to the right based only on that. Again, I can start at any point on the line, for example, the point 3, 2, and the slope tells me that for every 2 steps that I move up, I have to move 1 step to the right, and it'll bring me back to the line. I tend to decide if my rise is going to be up or down, and then depending on whether the slope is negative or positive, I'll decide whether I have to go left or right to make it to another point on that line. What about parallel and perpendicular lines? Well, if 2 lines are parallel, what's true of their slopes? Well, if 2 lines are parallel, their slopes will be identical. So if line 1 is parallel to line 2, then slope 1, the slope of the first line, will be equal to the slope of the second line. The situation is a little bit more complicated if the 2 lines are perpendicular, that is, if they're at a 90-degree angle. In this case, their slopes are negative reciprocals. So if line 1 is perpendicular to line 2, we find that the slope of the first line is equal to negative 1 divided by the slope of the second line, and vice versa. Let's use an example for that. That's the fancy way of writing it. There is an easier way to approach this. So for perpendicular lines, if the slope of the first line is positive 2 over 3, the slope of the second line, so m2, will be the negative reciprocal. In other words, positive becomes negative, and we take the reciprocal of 2/3, which is 3 over 2. Here's another example. If the slope of the first line is negative 4, the slope of the second line is the negative reciprocal. So it's positive 1 over 4, the reciprocal of 4 over 1. The situation is much easier for parallel lines if the slope of the first line is equal to 3 over 5. The slope of the second line is equal to 3 over 5. They are always going to be identical for parallel lines.